find the sum of the cubes of the terms of an AP and show that it is exactly divisible by the sum of the terms. Now sum of the cubes of an AP video I have already done, and I will give the link in the description of the video. So I recommend that you watch that video first, because in this video we are only going to show that the sum of the cubes of an AP is going to be divisible by the sum of an AP. Now in that video where we found the sum of the cubes of an AP, we found that S3, which is sum of the cubes of an AP, is actually n by 4 times 4a cube plus 6a square d times n minus 1 plus 2a d square n minus 1 times 2n minus 1 plus d cube times n minus 1 square, right? This was the sum of the cubes of an AP. We also know that the sum of the terms of an AP, which I am calling S1, is simply n by 2 times 2a plus n minus 1 times d. Now in order to show that S3 is always divisible by S1, we will consider the expression 4S3 by 4S1. Okay, the only reason we are doing multiplying by 4 is because we want to get rid of this fraction n by 4 and n by 2. Now if we can show that 4S3 by 4S1 is an integer, if we can show that this is going to be an integer, then we know that S3 is going to be divisible by S1. So what is 4S3? 4S3 is n times, and now we will open the brackets also. So we have 4a cube plus 6a square d n minus 6a square d. Okay, we are opening the brackets because we have to do the long division. Plus, now we know that this n minus 1 by 2n minus 1, this can be written as 2n square minus 3n plus 1, right? And similarly we also know that n times n minus 1 square can be written as n cube minus 2n square plus n, right? So once we know these two things, we know that 2ad square times 2n square is going to be 4 times a d square n square, right? This is going to be minus 6 ad square n, right? And this is going to be plus 2ad square. This is simply d cube n cube, d cube n cube minus 2 d cube n square plus d cube n, right? So this is 4s3. 4s1 is going to be, you have 2 times n multiplied to 2a plus nd minus d, right? 2a plus nd minus d, this is going to be n times 4a plus 2nd minus 2d. Right? Now, if we divide 4s3 by 4s1, we know that this n and this n will simply cancel out. So all we have to do now is the long division. Okay, we have to do the long division of, so we have to do, divisor is going to be 4a plus 2 times n d minus 2d, right? This is the divisor. The dividend is this expression over here, which is let me see if I can copy and paste. I can copy this expression and paste it here. Yes, so we have both the dividend and the divisor. Now 4a times a square, right? So we can write this as 4a times a square. So this is going to be 4a cube plus 2a square dn minus 2a square d minus 2a square d, right? And now if we simplify this, four a cube and 4a cube cancel each other. This becomes 6 minus 2 is 4a square d times n, and this is going to be minus 4 a square d, right? And now we have 4 a square d n here, so plus a times d times n, so we get 4 a square dn minus plus 2 a d square n square. So we have 2 a d square n square. We can bring this 4 a d square n square here. We get plus 2 a d square n square, and if I multiply this, I get d square n, a d square n, which is over here. So this is minus 6 a d square n, and I get minus 2 a d square n, right? So this cancels out, this comes down as it is, minus 4a square d. 4 minus 2 is plus 2a d square n square, and this is minus 4a d square n, right? Now we have minus 4a. Let us multiply this by minus a times d. So we will get minus 4a square d. Okay, we get minus 2 a d square n minus 2a d square n, which is over here. Right, and then we get minus 2a d square, minus minus plus, so we have plus 2a d square. We already have 2a d square here, so we bring this 2a d square also. Now if we subtract this, we get this cancels out, this comes down as it is, 2a d square n square, this becomes minus 2a d square n, right, and this cancels out. So we have minus, we have 2a here, we have 4a here, so we have to now multiply this by 1 by 2, right. So we'll multiply this by 1 by 2 times a is already here, we can multiply this by d square n square, right. So we multiply this by half d square n square, so you get 2a d square n square you get 2a d square n square, then you have half times 2 is 1, n cube d square, n cube d square, no, n cube d cube, n cube d cube is here, right. So we get plus d cube n cube, which is also here, so we bring this down, plus d cube n cube, and this is minus 1 d cube n square. We have d cube n square somewhere, yes, this one is d cube n square actually. So we have minus 2 d cube n square, and we have minus d cube n square. Now again this one cancels out, this comes down as it is, so let me write it here, minus 2a d square n, this cancels out and you are left with minus d cube n square, and you have minus 2 here, so you multiply this by minus 1 by 2, and you already have a, so you multiply by d square n, so you get minus 2a d square n, this becomes minus n square d cube, so this becomes minus d cube n square, and the last term is minus minus is plus half d cube n, so we have d cube n over here, so we bring this down, so we get d cube n plus d cube n, and finally we see that the remainder is going to be 0, right. So our division is complete, so we have this cancelling out, also this cancelling out, this cancelling out, and our remainder is 0. So what is our quotient after dividing? Our quotient after dividing is q is equal to a square plus adn minus ad plus half d square n square minus half d square n. So this is the quotient that we got after dividing. Now we only have to show that this quotient is going to be an integer, and it is very easy to show because quotient is actually equal to a square, which is an integer, plus adn, which is also an integer, minus ad, which is also an integer. I can take half d square n as a common factor out, and you will be left with n minus 1, right? I know that d square n is also an integer. All I have to prove is that a square plus adn minus ad plus d square n is also an integer. All I have to prove is that, in fact, d square is also an integer. All I have to prove that n times n minus 1 divided by 2 is an integer. And we can see that if n is even, then n minus 2 is odd. But because n is even, n by 2 is going to be an integer. Suppose n is odd, then n minus 1 is going to be an integer. And so suppose n is odd, then n minus 1 is going to be an even, and still we will be able to divide it by 2. So all I am saying is that n times n minus 1 divided by 2 is always an integer. Okay, so that is why we know that this term is an integer, this term is an integer, this term is an integer, and this term is an integer. So q is an integer, and we are done.